This is part 2 of the Oneway ANOVA, looking at the relationship between feedback and parking ability. In the last video, we summarized our data and we calculated our 3 basic ratios, and the answers are listed here at the bottom. So our next step is to calculate our sums of squares, and our first sum of squares is our sum of squares A. The formula for this is quite simply the basic ratio for A minus the basic ratio for T. So we have 138 minus 85.33, and that equals 52.67. Our next sum of squares is our sum of squares S over A, and the formula for that is the basic ratio for Y minus the basic ratio for A. So we have 146 minus 138, which equals 8. And last but not least, we have our sum of squares T, which is the basic ratio for Y minus the basic ratio for T. And so we have 146 minus 146 minus 85.33, and that equals 60.67. And before you move on, you want to make sure and check your work. So your sum of squares A plus your sum of squares S over A should equal your sum of squares T. The other thing you want to do, I haven't mentioned this consistently in all the videos, but it's really important. You want to make sure that your sums of squares are positive numbers. If you get a negative number, you've done something wrong. You've either reversed the scores here, you've reversed the formulas, or you did not correctly do the check for the basic ratios, because you should never get a negative number for your sums of squares. All right, once we have our 3 sums of squares, we are ready to calculate our degrees of freedom. And we have a degree of freedom to match up with each of our 3 sums of squares. So our first degree of freedom is your degrees of freedom for A, and the formula for that is simply little a minus 1. So our little a in this problem is 3. Oops. So 3 minus 1 is 2. Our next degree of freedom is our degrees of freedom for S over A, and the formula for that is little a times the quantity n minus 1. So our little a is 3, our little n is 4, so 3 times 4 minus 1 is 3 times 3, which is 9. And last, we have our degrees of freedom T, and the formula for that is little a times little n, no parentheses, minus 1. So we have 3 times 4 minus 1, which is 11. Just like the sums of squares, these should add up, so your degrees of freedom A plus your degrees of freedom S over A should equal your degrees of freedom T. And also, your degrees of freedom T should be 1 fewer than your total number of observations. So you have 12 observations up here, and your degrees of freedom T is correctly 1 less than that. All right, once we have, there's my dogs. Once we have our sums of squares and our degrees of freedom, we are ready to calculate variance. So remember, in the ANOVA, we refer to variance by the term mean squares. Okay, we don't call it variance anymore, we just call it mean squares. But basically what we're doing in the mean squares is we're calculating a variance. And remember, the overall formula for a variance is the sum of squares divided by our degrees of freedom. So you can see we've calculated some sums of squares here. We've calculated some degrees of freedom here. We're going to match those up and calculate some mean squares. So the first mean square we're going to calculate is the mean square A, and that is equal to the sum of squares A divided by the degrees of freedom A. So our sum of squares, A is 52.67. Our degrees of freedom A is 2. And so when we do the math on that, that equals 26.34. Next, we have our mean square S over A. Hi, buddy. Next, we have our mean square S over A. And our formula for that is sum of squares S over A divided by degrees of freedom S over A. So our sum of squares S over A is 8. Our degrees of freedom S over A is 9. And so that equals 0.89. Now we could calculate our mean square t, but we don't really need it for anything. There's nothing we can do at this step like the previous steps. There's nothing we can do to check our work. Our mean square should be positive, but that's about it. They don't add up. There's not one that's necessarily going to be bigger than another one. And we don't really use the mean square t for anything, so we're not going to even spend the time calculating that. But once we have our two mean squares here, we are finally ready to calculate our F ratio. And the formula for the F ratio is our mean square A divided by our mean square S over A. That's a little bit messy, but it's the mean square A divided by the mean square S over A. So we've got 26.34. Sorry for all the sound effects in the background. We've got 26.34 divided by 0.89. And remember, the formula for the F ratio is the between subjects variability divided by the within subjects variability. And in this problem, our between subjects variability is MSA, and our within subjects variability is MS over A. So when we plug these numbers into our calculator, we should get 29.6, and that is our F ratio. So when we come back in the third and hopefully final video, I'll put together the ANOVA summary table and we will go through the steps of evaluating this F ratio. Now, before I end, I just want to give one kind of pointer as you are trying to figure out whether you are rejecting or failing to reject. And again, we're gonna cover that in the next video, but just one kind of pointer that I always like to tell students is the bigger your F ratio, the more likely it is that you are going to be rejecting. So in general, bigger means you're going to be rejecting. Now, it's not, I can't give you a hard and fast rule here because it really depends on how many groups you have. It depends on how many subjects you have per group. So as you know, if you've been following along, the critical F varies depending on, what your problem looks like. But a general rule of thumb that I give to my students is if your F ratio is greater than 10, chances are it's going to be a reject. All right, so bigger F ratios are reject, and if it's greater than 10, the chances are very likely that it's going to be a reject. So before we even get to the third video where we summarize the data here, where we put together our ANOVA summary table, we can look at the size of this F ratio, 29.6. That's bigger than 10, so there's a good chance this is going to be a reject. But we'll go through all the steps in the next video to see if that's for sure.